Welcome DIKWP, 小工 aboard. Your learning journey starts now. Ever felt like AI in energy systems is just a black box, churning out decisions without a soul? We're drowning in data from smart grids and sensors, but does it mean anything? That's where DIKWP steps in, not just another buzzword, but a framework that gives AI a semantic backbone, turning raw numbers into purposeful action. Think of it as giving your AI brain a clear mission. So, what's the magic behind DIKWP? It's elegantly simple, 5 layers. Data is your raw input, the sensor readings, the logs. Information is when you give that data context, like spotting a load spike. Knowledge is the accumulated wisdom, the rules, the models, the why. Wisdom is where the real thinking happens, weighing options, making strategic calls. And purpose, that's the North Star, the ultimate goal, like hitting carbon targets or ensuring grid stability. Crucially, these aren't silos. They interact in a closed loop. Purpose guides wisdom, which uses knowledge to interpret information derived from data. If something doesn't fit, it gets checked, corrected, optimized. No drift, no ambiguity. It's a self-correcting cognitive engine. Let's ground this in the real world, power grids. The challenge is immense complexity, safety-critical operations. How do we apply DIKWP? Simple mapping. Your D layer is all that sensor data, voltage, current, weather, impacting renewables. I layer turns that into actionable insights, load forecasts, fault alerts. K layer is the deep stuff, physics laws, operational rules, optimization algorithms. W layer is the dispatch center's brain, balancing generation, cost, and reliability, maybe even prioritizing green energy. And P layer, that's the big picture. Keep the lights on, minimize costs, hit those sustainability targets. By structuring AI around DIKWP, we move from reactive monitoring to proactive, semantically aware grid management. It's about making the grid truly intelligent, not just automated. Now, let's zoom out. What if we have multiple DIKWP systems interacting? Like a smart city with energy, transport, health systems, all running on this model? That's where DIKWP times DIKWP comes in. Think of it as combining the general structure with specific instances. At the city level, you get city data D, merging everything. City information I reveals correlations, like heat waves correlating with power demand and hospital visits. City knowledge K connects these dots, linking traffic patterns to air quality, or grid failures to potential transport chaos. City wisdom W makes cross-domain decisions, say, shifting office AC usage off-peak while ensuring hospitals stay powered. And city purpose P aligns everything towards overarching goals like sustainability or resilience. This isn't just integration. It's creating a truly unified, adaptive urban intelligence fabric. So, why should you care about DIKWP? Because it tackles the core problems of AI in complex systems. It provides explainability. You can trace the logic behind any decision, crucial for critical infrastructure. It ensures consistency through that closed-loop mechanism. It scales beautifully across different domains, from power grids to communication networks to entire cities. DIKWP isn't just a theory. It's a blueprint for building AI that understands, reasons, and acts with purpose. It's about moving beyond mere automation to creating truly intelligent, trustworthy systems for our future infrastructure.